if you're trying to find the relationship between two variables, so the first thing we're going to do is construct a scatter plot. So the scatter plot gives us at least some sense of the overall pattern, and that'll help us determine the nature of the relationship between the explanatory variables that sits on the x-axis and the response variable that sits on the y-axis. Now you can describe the pattern by its direction, its form, and its strength. So let's think about the direction of the relationship between two variables. Now suppose we have the explanatory variable and the response variable, and a scatter plot that looks like this. So what we see here is a positive association. So what do we mean by a positive association? What we see here, based on the pattern from the scatter plot, is that as x is increasing, you notice that y also increases, and that's what gives us the rising line. Now if x increases and that results in y increasing as well, this would be called a positive association. Now if the association between x and y is positive, we cannot assume always that the pattern is linear. It could even be a pattern that is curved. So even in this case, in the second example, you see that as x increases, y increases as well. So this association is also positive. But in this class, we're only going to be looking at linear association. So we're not going to come across problems where the association is not linear. So we're only going to come across linear associations. Now suppose we make a scatter plot, and what we notice is a pattern that looks like this. So the overall pattern that we see here is that of a falling line. So as x increases, what we notice here is that y decreases, and that's how we get the falling line pattern. So this pattern represents a negative association. So we're only going to be dealing with the patterns of a linear form or a straight line form. So this is a negative linear association between the two variables. Now let's look at a few examples here. So the first graph here, which is titled Nevada. If you look at the overall pattern, it looks somewhat like the graph that I just sketched. So this looks like a negative linear association. So it's definitely a negative association, which means, as in this case, elevation increases, the mean annual temperature is decreasing, and that's how we get the falling line pattern. Now let's look at this second example. Here is a graph. We're looking at a graph and looking at the overall pattern. The pattern looks like a straight line that is rising. So as x increases, we see that y is increasing as well. So the points are moving up, which means as x increases, y increases. So the way we'll describe this pattern or the relationship between the two variables would be x increases, y increases linearly because the pattern is clearly a straight line pattern. So it's a positive linear association. So positive because that's the direction in which the graph is moving in the positive, and linear because the pattern is linear. So this is called the direction. When I say what's the direction, there are two directions, positive or negative, and this is called the form. Now let's look at the next graph. The pattern is different from what we've seen so far. So overall, the pattern looks like a curve. So here, it's clearly not a linear association. Now in the next example, up to a certain point, it looks like a straight line, possibly, but then it looks like it's curving after that point. So it's not really a straight line relationship, although you can call this a positive association. It's not a linear association. In this chapter, we are only going to come across linear associations. That's all we care about in this course. So those are the kinds of problems you're going to see. But I just wanted you to be aware that those are not the only types of relationships between two variables. Let's look at question 5 from the textbook. So the question says, do heavier people burn more energy? So there's two quantitative variables here. So when we refer to heavier people, we're talking about body mass, and that would be the lean body mass that's measured. And metabolic rate is the rate at which the body consumes energy. There's a way of measuring that, and it's measured in calories. So these are the two variables. So based on what we've read in the question, if you can pause the video and read the question, you'll see that we want to see if body mass affects the metabolic rate of an individual. So this becomes our explanatory variable, that is mass, and the metabolic rate would be the response variable. In addition to that, we also have the gender, and that would be another variable, of course, but the variable here would be categorical because it's gender, and that could be male or female. So if we graph these data, we can obviously put the mass, lean body mass, on the horizontal axis, and the metabolic rate, which depends on the body mass based on what we've read in the question, on the y-axis. Now, there is a nice way of including the categorical variables in the graph by assigning a different colored point for females and maybe another color for male, and that way we can see the two subjects in the same graph. You'd see the point represented by a red dot or a red circle would be a male, and maybe a blue square could be a female. So there's a way of doing that in Crunchit as well. So that's somehow incorporating a categorical variable into a graph. So this is the graph that I get using Crunchit, and if you look at the overall pattern, let's look at all points, the male and the female. The overall shape of the graph looks like roughly a straight line that is positive, a rising straight line. So it's a positive linear association between lean body mass of an individual and the metabolic rate measured in calories. But notice, however, that the points are different based on the color. Notice that the red is for the male subjects and the blue is for the female subjects. So if we just look at the female subjects and ignoring the male subjects completely, you'll notice that the graph, let me just find another color. So if you just look at the female subjects, then maybe the yellow line would represent the pattern or the nature of the relationship between lean body mass and metabolic rate for women. But if we look at it overall, then we could say it's the green line. It looks more or less the same overall. So it's a positive linear association. So it's positive and it is linear because it's a straight line. So let's look at all the variables represented in this graph. So we have the lean body mass on the x-axis, the calories on the y-axis. We also see the different points, some blue and some red, which indicate the male and female subjects. The only thing missing is the subject number. Now obviously each subject is represented by a point, so the subject number is not really the variable of interest here, so that's why you do not see it on the graph. Now let's look at this scatter plot and see if there is a clear pattern forming in this scatter plot. So let's look at it. Do you notice like a straight line relationship when you try to think of the overall pattern or the overall relationship between the two variables? It looks like a straight line that's rising. So we could say that the relationship is positive linear. So positive tells you something about the direction, and this is the form. The form is linear. That's the graph it's forming. The next thing that we could say something about is the strength of the relationship. Now when you look at the pattern that we said that the two variables are forming in this scatter plot, that the points are forming in this scatter plot, we said it's linear. Now, how clear is the linear relationship when you look at the scatter plot? Are the points forming a clear linear relationship? The clearer the graph, the pattern, the stronger the relationship. If the pattern doesn't seem very clear and you have to try hard to establish a pattern or see a pattern in the scatter plot, the relationship is weaker. So, for example, if I have a scatter plot that looks like this, do you notice that it is forming almost a perfect straight line, just a little off? So the pattern that we notice seems to be very clear from this scatter plot. The clearer it is, the stronger is the relationship. So here the relationship between the two is very strong. Here we could say that it is strong. The relationship is strong because the pattern is quite obvious. Now, the harder you have to try to establish a pattern, the weaker the relationship is. So, for example, if I have a graph that is like a scatter plot that is like all over the place and it's really hard to see what's going on, you could go either way, then you would say that the relationship is weak because it's not forming a clear pattern. So the general rule is the clearer the pattern revealed in the scatter plot, the stronger is the relationship.